Before time could be measured, it had to be felt. Morning arrived with light, not numbers. Work ended when shadows stretched long.
But merchants, priests, and rulers needed more than intuition.
They needed repeatability. They needed something that could move when no one touched it. That could divide the invisible flow of time into equal, obedient parts. The first clock was not born from elegance.
It emerged from weight, friction, and stubborn trial.
The process began with metal pulled from the earth.
Iron ore was broken by hammerstone.
Smelted in charcoal-fired bloomery furnaces. Where air was forced through leather bellows by human rhythm alone. The result was a rough bloom of iron, spongy and impure.
Reheated and beaten again and again to drive out slag.
Each strike rang dull and heavy.
Reshaping matter into obedience.
Brass and bronze followed. Copper was melted with tin, poured into simple clay molds. Then cooled slowly to avoid cracking. These alloys mattered. Iron alone was too rough, too eager to seize and grind itself to dust. Brass slid.
Bronze endured.
The inventor learned this the hard way. After early wheels seized mid-rotation, frozen by their own weight. Wood came next. Oak, chosen for its tight grain and resistance to warping. Cut during dry months, so sap would not rot the mechanism from within. The boards were seasoned for years, not weeks. Stacked with spaces to breathe, to forget the forest they came from. At the center of the idea was motion that could regulate itself. Earlier timekeepers already existed. Sundials that depended on the sun. Water clocks that relied on flow. Candle clocks that vanished as they worked. All failed in darkness, cold, or inconsistency.
The breakthrough would not come from observing nature, but from resisting it.
The inventor began with a falling weight. A stone, drilled through its center, suspended by a rope wound around a wooden drum. Gravity was reliable, relentless. As the weight descended, the drum turned.
This much was obvious.
The problem was speed.
Left unchecked, the weight would fall too fast, finishing its work in moments.
The first attempts used friction alone. Leather pads pressed against the drum.
Wooden pegs dragged along frames.
Each failed differently. Some slowed the motion unevenly. Others wore down within hours. Heat built up. Smoke appeared. Time slipped. Then came the wheel. Not a smooth wheel, but a toothed one.
Teeth carved by hand, each angled deliberately, filed again and again to remove burrs.
That would catch and stutter.
This wheel engaged another. And another. A train of gears, each reducing speed, multiplying force, at translating vertical fall into rotational persistence.
But even gears were not enough.
The weight still accelerated.
The realization came slowly, after watching water wheels in rivers.
After noticing how paddles resisted flow, not by stopping it, but by letting it pass in measured intervals.
The solution would not block motion. It would interrupt it. The Verge escapement was born from this insight.
A vertical rod was forged, its ends bent into pallets.
Shaped to alternately catch and release the teeth of a crown wheel. Each release allowed the wheel to advance by a single tooth. Each catch halted it again. The first verge was crude. The pallets were misaligned. The crown wheel teeth were uneven. The clock ticked, then stalled, then surged forward unpredictably. Hours were lost. Days drifted. Failure taught precision. The inventor learned that symmetry mattered, that a tooth filed a fraction too deep would alter everything, that metal expanded with heat, wood with humidity. That friction was an enemy that could never be defeated, only negotiated with oil rendered from animal fat. It filtered through cloth until it ran clear. Still, something was missing. The escapement controlled release, but not rhythm.